Hello everyone, welcome to my channel EC on Tips. I am Samiksha Shrivastava. In today's lecture, I will be teaching classification of materials based on the energy bands. So in the previous lecture, I've already told you about what is the valence band, conduction band and the band gap between them, right? So what is the valence band? Where the free valence electrons are present. What is the conduction band? Where the free electrons are present. And the band gap is the separation between the two. Now, if the band gap between the valence band and the conduction band is in the range 5 to 10 electron volt, then it will be an insulator. And if the band gap is nearly equal to 1 electron volt, then it will be a semiconductor. And if there is no band gap, then it is a conductor. Okay. So what is this energy? This energy is the amount of energy required by the valence electron to move from valence band to the conduction band. Okay. So this is the amount of energy required by the valence electron to move from valence band to the conduction band. So this is the energy. So less amount of energy is required, or the no amount energy required is in the conductor. Then it is in the semiconductor, then the insulator. So their conductivity will also be in this order. That is, conductors' conductivity will be definitely high, then it will be of semiconductor, then insulator. Now to understand the actual conduction process in semiconductor, we have to understand this. So you all know that at 0 Kelvin temperature, the semiconductor, it acts as an insulator because there is no electron available in the valence band. In the conduction band. There will be no electron present. And for the understanding purpose, I have made this diagram. That is, this is a semiconductor and we have applied a voltage across it. But for the understanding purpose only, I have made this diagram, but the actual diagram is like this. This is the actual diagram. Okay, this is the actual diagram. Why? Because the electric field is in this direction. The electric field is always sar utha ke jeeti hai, and hence the energy band will be in this way. Okay. So first we will understand about the conduction process in 0 Kelvin, and then we will go to the normal temperatures. Okay. So you can observe over here that in this valence band, all the electrons are present and there is no vacancy here. All the vacancies are present, or all the vacancies are present in this conduction band. Okay. All the vacancies are present over here. So as you can see, the electron cannot move over here. Why? Because there is no vacancy present. Here already electron is there. And this electron cannot move over here because their electron is already present. So if the movement of electron is not possible, hence there will be no flow of current. Right? Because flow of electron is responsible for the current flow. And hence there will be no flow of current. So in the statement also I have given that by electric field, only by applying the electric field, we cannot allow the flow of current in this whole semiconductor. Okay, we require some amount of temperature or the light so that will help the electron to move from valence band to the conduction band. Right? If we apply some amount of temperature into this semiconductor, what you will observe that this electron will leave its place and it will move to the conduction band. And this electron will also, so if there is a vacancy present, okay, here you will observe a hole. So this electron will move to this hole and here again a vacancy will be present. So this vacancy will be fulfilled by this battery. So this battery will provide the electron and this will go. And as this electron is moved over here, so here is an excess of electron. So this electron will move over here. So one electron is moving out from the battery and one electron is entering. Hence it is a balanced flow. So if we apply some amount of temperature, then this will happen. But we are talking here 0 Kelvin, hence nothing will happen over here. So hence it will only move, the electron will only move if we apply some temperature or the light. That will only provide it the energy to move from valence band to the conduction band. Okay, so at 0 Kelvin temperature, no motion of electron, and hence no current will flow in this, and hence conductivity will be 0. So this will act as an insulator. That is why we are saying that in insulator there is no flow of current, or there will be no conduction happening. Now if we understand for temperature, that is 300 Kelvin, or you can say the normal temperature. Okay, so at this temperature what you will observe that all the electrons are present in the valence band, but we have provided some temperature. Then what you will observe, this electron will leave its place and move to the conduction band. Okay, as it moves to the conduction band, here hole will be created. So this hole will be filled by this electron. This electron will move to this place, and here again a hole will be created. As this electron is here, so this electron will again, this electron will move over here, and this electron will move over here, and hence this electron will move, and it will go like this, and this electron will move like that, and here vacancy will be fulfilled. The transfer of electron can take place because here one electron has moved from valence band to the conduction band, and hence vacancy created. So this electron can move, so the movement of electron can takes place. So you can observe there, here is that one flow of electron, you can observe here is that flow of electron can lead to the current, right? So if the electrons are moving in this direction, if the electrons are moving in left to right direction, so then definitely the current will move from this direction. If electron is in this direction, then definitely current will be in this direction, right? So the current I1, you will observe it like here in this direction. And you can also observe over here that here holes are present, right? Holes everywhere. But here one electron is present. So this electron will again move to this. Okay, here electron is present, hole is again created. This electron will move over here and again, and this electron will be given to this, and this electron again this, and hence there will be a flow in the conduction band as well, right? This is the separate flow in the valence band, and this is a separate flow in the conduction band. Are you able to understand the two different flow of current due to the valence band and due to the conduction band? So here also you will observe that the electrons are moving in this rightward direction, and hence the current will flow in this leftward direction. So you can add these two current, I1 and I2. I1 is due to the valence band and I2 is due to the conduction band, and hence net flow of current will be I1 plus I2, and hence there will be a flow of current in this circuit. And this is the semiconductor case. Why? Because by applying the small amount of temperature, here we require this small amount of temperature for the electron to move from valence band to conduction band, and then there will be a proper flow of current, or the conduction will happen here. But if the case will occur like in insulator, where you have to apply, where you have not applied any temperature, then this will case act as an insulator. So this is an insulator case, and this is a semiconductor case. Okay, so this is all from my side. Thank you so much for watching my videos, and please subscribe to my channel. That will motivate me to make further more videos. Thank you.